so it's very tired over there.
Where are you located? Where are you based out of?
So actually, I'm in West Bengal right now, India.
Where?
West Bengal.
वेस्ट बंगाल ओके वेस्ट बंगाल में कहाँ पे बताया वेयर
Sir, in West Bengal, Kolkata.
कोलकाता लाइक मेन कोलकाता और हावड़ा
Main Kolkata.
आई सी वेयर इन हाउ फार
Sorry.
फ्रॉम राजारहाट
Uh, let's see. 45 minutes.
आई सी नाइस हाउ इज इट इन वेस्ट बंगाल
Sorry.
हाउ इज इट देयर डू यू फील लाइक मूविंग टू बैंगलोर
Um, I didn't live in Kolkata in all my life, so it's a bit new for me.
व्हाट
I mean, I never lived in Kolkata for a long time. It's just a bit new for me. I've always lived outside or in Surat.
वेयर वर यू
I was in Saudi before.
आई सी हे शुभोध
Good evening, Sandeep.
हाय गुड इवनिंग good I'm looking yeah cool good everyone keep the cameras on make it feel like a class it's okay yeah thank you Shrish how are you yeah
Yeah, fine.
feels good and how is in Calcutta is it hot or how's it
It's extremely hot.
I think Subodh you are in the US right oh no you are in
Vancouver.
Vancouver yeah you are in the PST
PST. Yes.
oh it must be say 7:30 for you right 7:30 p.m
7:30. Yep.
okay all right everyone please keep your cameras on make the class lively it's okay in wherever you are whatever you're doing it's okay to keep the camera on it actually feels really nice thank you Gaurav thank you so much okay it's like 10:30 for me and I don't feel drowsy so I'm just keeping my this thing standing table and yeah and when I see people and faces it feels really good it keeps my energy really high thank you Sanish thank you so much um, perfect all right so I hope everybody is doing good and did you guys work on some of the exercises that I gave last time no
I mean, I started off working on the recursive one, the string one, but I couldn't complete it. Maybe by tomorrow I'll submit the assignment. Yep.
okay which one was it recursive string
The
permutation
the get permutation, right? Not using the permutation.
library right yeah
Yes.
Sandeep, I tried, I just pasted something in the chat. I'm getting issue when not using, that function, what I submitted. So maybe I need your help.
okay that's a good thing to discuss actually
Yeah.
okay all right so let me share my screen and get ourselves started keep this class as much lively as possible ask lots of questions disturb the class a little bit it's completely okay what's not okay is just silently listening and being uh, the classically the good student in our traditional classes where you are very good student and you don't ask any questions and so it's completely okay I actually love it when there was somebody who asked me multiple questions and it's completely okay and the same thing is for like my teams I mean most of the people who worked with me in my previous startup as well as current startup everyone, I have always wanted them to be like owner, and it's completely okay to question anybody, including myself. So yeah, even the class, I think that's the beauty of this class, that the people who finish my sessions are like the people who attend my classes usually are unmanageable to other people. When somebody else takes up the class, it becomes very difficult for them. Okay, because everybody is very comfortable asking questions. So I would want everybody to ask as much question as possible. It's completely okay to stop me and say, hey, Sandeep, this is not at all clear to me. Can you repeat it? And it's okay to, I can repeat multiple times. It's completely okay. And every time I do that, I'll probably try to choose different set of words to explain the same scenario. Okay. So there's no harm, there's no shame in asking me again to explain again. It's completely okay. And it's also completely okay to ask in even the questions that, hey, I missed this earlier, can you explain again? Okay, so that's the most important part, because videos, lectures, theory, content, all of this is available in every book, every video. There's millions of video, million of content on internet. What is not available is that the doubt. Okay, and I'll show you how much you will get doubts as we go ahead, including today. A simple piece of code will look really complex when you try to solve it and when you see that thing. So I think most of the things that I'll throw in the class at you, I would be expecting that you ask questions. Okay. I would be expecting that you ask questions. If you're not asking questions, most likely you are not listening and paying attention. Okay. So ask lots of questions. There's no saying. And for me, it becomes very difficult if people are not asking questions. I start feeling that I have probably zoned everybody out. Okay, everybody has gone to. Okay, so I will change the name to this notebook and I'll call it 17 May. I'll just call it ML.
There's nothing generally. Which section of the course are we in for today? Just want to make sure.
Okay, good point. Yeah, so I am going with this flow. I'm going with this flow. Okay, and yeah, so if you guys, I'm not sure if you are able to access it. Okay, let me just share this folder with everyone. Copy link. I'm just sharing. Let me click on share. Okay, just in case you don't have access to the entire thing, I'll share the folder link to everybody. You can keep a copy, download it to yourself. Don't share it with anybody. In case you're planning to use it, just ping me. Let's say you want to teach someone, a friend or somebody, or you want to run some classes on Python, feel free to use them. Just in case you want editable one, just ping me. I'll share with you the editable one and just give me a little bit credit. That's all. Okay. And yeah, it's very common that most of my students, wherever they are, what they do is they present talk on machine learning or anything. They usually ask me that, can you give me this particular slides? So it's completely okay for my students. All right, so this is the exercise. Nice. Okay, and I'll just run it. This is how you run it. Okay. All right. Okay. Okay, never mind. I'll come back to this. I think this is a little advanced for everyone. Okay. Yeah. So I'm going with this flow. There was a question somebody asked. I'm going with this flow that we talked about a brief about motivation on why do you want to use Python. Then we talked about variables, expressions, and statement, like you can just assign values and they can hold the values and so on. Then we talked about if and else conditions. And today we are going to talk about functions. Okay. Functions are the most powerful thing that you will need to know. It's such a simple thing, and at the same time, it is such a complex thing. Okay. And truly speaking, honestly speaking, specifically recursiveness, I will talk about recursiveness, is something that is the most innovative thing that you'll learn. Okay. I'll have a lot of things on recursion. And probably the more exercise you do on recursion, the better you will get. Okay. Yes, go ahead, Rahul. You're on mute, Rahul. You want to say something?
Sorry, I was talking on mute, but just want to check the use cases around recursion. I know it's help in, simplifying the code, but in what exactly, in which situations we'll have to use it on, to sort out like the real problems.
I'll show you. Everything.
Yeah.
Everything. Okay.
Everything.
Yes.
Okay.
Okay. I'll show you the magic. The compilers are written using recursion. The SQL parser, everything is written using recursion. And it's the most novel thing that we start. The interesting part is that all the people who have not coded much or have not coded, like in school, we had algorithms chart, right? You draw the chart.
Yeah.
So there was something for loop, something for this and that. But for recursion, I could not find a symbol in those charts. Okay. And I think so. I'll just share this tiny story that I was in second year, and there was this contest, and the context was that you have to basically give in numbers. Let's say if the input is n equal to 2, so you have to draw 2 squares in all possible combinations. This is first combination, this is second combination. When n equal to 3, you have to draw 3 squares in all possible combinations. Okay. Now help me. Who can help me? All possible shapes you can make. And that's it, right? Is that it? 1, 2, 3, 4, 5. Oh, I forgot.
6. Yeah.
Yeah, correct. So, and at the same time, if it's, let's say, n equal to 4, then things go crazy. 1, 2, 3. I think it'll be like 24 or something. Okay. So this was the contest, and one senior had solved it in like 20 minutes. And till this point of time, I did not learn coding. And I was wondering, like, I myself can't figure out an algorithm to solve it. Then how will the computer figure out? Okay. And essentially, the answer was that we got to just try out all possible permutations, and that's about it. And to do that, if you do that using, say, recursion, it's easy. Similarly, when I saw somebody write a code to solve, say Rubik's Cube with that, right? Or solving some other random puzzle, I was actually puzzled that how would you write code on these? I very vividly remember. And I even asked like a couple of people, like seniors, that how can you write and how can you solve a puzzle that you yourself can't solve? Like once I saw somebody that 15 square puzzle is there in which you move it. There is a 4x4 grid and only one is missing, and then you move them around to make shapes.
Yeah.
Right? Then how do you solve that kind of problems? Okay. And that's what got me, very puzzled about like coding, that how do you do it? Okay. So I think let's start. So perfect. So one of the coolest part about the computing is functions. Functions is, in simple words, you group the statements into together and give it a name. Like for example, instead of, let's say you want to print hello and fun multiple times. So what you do is you basically put them together and then execute it. Okay, like for example, you want, let's say, where is my code? Okay, let me separate the windows so that I can quickly sift between them. Okay, let's say, let's say you want to define a function. Let's say you have to turn the robot, okay? Turn your robot. Okay, so what will you do? Let's say you have a robot which have these functions like left, right. Okay, this will turn 90° left, 90° right, and forward and reverse. Okay, so this will basically turn. Okay, now okay, how would you make it turn around? How would you make it turn around? Okay, move forward, move reverse. So these are the commands that are existing in your robot. Okay, turn left, turn right, move forward, move reverse. How would you turn the robot 180 degrees? Anyone? You will turn left and again turn left. That will become turn 180 degree. Correct? And right now, if you turn twice this way, you will basically able to turn 180 degree, right? So instead of every time typing these two commands, what you can do is you can define a new command saying turn around, okay? And you can put them together. Now, when you call it, when you call turn around, it will basically turn it around, okay? Like for example, here, print left, okay? Print left. So when you say turn around, okay, I'll just comment out this piece of code. Okay, when you say turn around, it will basically call these two prints in a single shot. Okay, so basically the turnaround command, you just created a function. So the print function that we have been using is a function, right? So you can basically call the same function again and again and again and again. Okay, so now let me now show you something really cool. Okay, let me say that I am having something called read. All right. Now I'm starting with suddenly with something interesting. Okay. So what you see is the turnaround is calling the function print, then calling the function print, and then coming out, right? So up to here, everybody is okay? Like you can define a function which can do things.
Yes, Sandeep.
Cool. Now, Now, the great part about functions is that they can call themselves. Okay, so I'm going to say read input. Okay, enter something. Okay, enter a word. Okay, if text not equal to dot, then read. Okay, and then print. Now, here is a cryptic work, though, right? I enter A, B, and dot. Okay, so what I did, I'm reading from the user the text. Okay, I'm reading from the user the text. Okay, and okay, as soon as the user is entering dot, I am sorry. As soon as the user is entering something, I'm reading it. If the thing that user entered is not dot, I am again calling the same function. It is coming here. Again, it's reading the text. Again, I'm checking if it's not dot. I am again calling this. And then it's going in circles. Okay. And the moment I'm saying text equals dot, I am coming out of it. Then it's not calling again. Okay. Now, what would be unsettling about it? This is a cow. Okay, full stop. Now, you notice this here, okay, that the moment it encountered dot, it basically just came here, printed the dot. Then it printed cow, then it printed A, then it printed is, then it printed this. Is this code clear, everyone? Are you guys on the same page?
Yes, Sandeep, I have one doubt. How to
Hmm.
text is appending the all previous string entering the text, like dot,
Exactly,
yeah.
exactly,
Okay.
exactly. I, I want everybody to, ponder over this for a moment. That why is it so? What's actually happening here?
And Sandeep, even one more question. How the, text get reversed?
Exactly. That's another magical part, right?
String is appending because string is immutable.
That's right.
And the reason why it is reverse is because it sort of um, starts with the first word and then goes to the end, and then it is like stacking work, right? So it puts on the work on a side and then starts popping it out. I don't know if I explained it rightly, but it's like
You are
stacking
there.
it up.
You are there. Yes. Yes.
So Sandeep, your text is the every time assign a new memory for the new entering word, or the
Yes.
same memory is stating the all
Yes.
words?
Yes. So let me show you this. I will first remove this part. Okay. I will show you this. Okay. So I hope read text. Okay. And I just defined a function called read text. Okay. So whatever I am reading, okay, it's saying, okay, enter, let's say, enter your name. Okay. And I'm saying print and welcome, welcome, text dot, let's say upper, I'm just for the sake of this. Okay. So let's say I entered Sandeep. Okay. So it says welcome Sandeep. Does it make sense to you? No? It's okay, right?
Yeah.
Yes, yes.
Okay. Now, a question to all of you. I'll just remove this space. Okay. Let's say we say support. Okay. So is this a piece of code clear to everyone? So we just wrote a function which has two instructions. First instruction is this, and second instruction is print. So in the first instruction, it is asking you to enter the text, and then it is printing welcome, followed by the text that you are entering, converted to the uppercase. So text is a string, is a variable called string. String has a method called upper, and we are calling that on the text. Correct? Now, question to all of you is that uh, here, I think this piece of code is okay with everybody. Those who are new to Python, those who are new to programming, is this piece of code clear to everyone? So input shows this text here to the people. And then when somebody types in something and presses enter, that text is set into this variable because the output of input is assigned to text. So whatever input gives in, it goes into text, and here we are printing it. Okay. All right. So everybody, I know that many of you are new to programming, and I just want to get a feedback whether everybody's okay. It's okay. There is no, even if you ask me that, can you explain again? I would be okay. All right. Perfect. Right. Now, so whenever I am calling this function, it is calling back that other function, right? Whenever I'm calling this function, it is calling this, whatever it is, it's getting called. Now, if I define for a moment, if I, let's say, define another thing, enter your name, if text not equal to dot, okay, it's going to call, this is my read text one, and I am going to call this here, okay, and so on. All right, now, and I'm just showing you what's happening, okay? So I've just copied this code, okay? So let's say this is my function, and this is another function I've defined. The only difference between this function and this function is that if somebody is not entering dot, it will call the other function, and then it will do the rest. So let's take a look at what's happening here. When I call this function, what happens? It asks me for, let's say, my name. Say I say Sandeep. Then it asks again, Giri, and then it prints Giri first and then Sandeep. Are you guys able to walk through this code? So when I ran this one, what happened? I came in here. It came in here. It read the text. Then since it was not dot, it called this function. And here it again read the text. And once it was done reading text, then it printed it. It printed the text. The most recent one gets printed first. Okay. So first I entered Sandeep here, correct? So here there was, is the font okay, or should I increase the font? Okay.
It's fine.
So when I entered Sandeep, the control was here. Okay. The control was here. And the Sandeep went into text, and it checked, is text not equal to dot? Of course, Sandeep is not equal to dot. Therefore, it went into this another function where it again read this, right? So this, let's say, line number 1, 2, 3, 4. Let's take a look. So this 1 is coming from here. This is line number 1. This line number 1. when you enter your name is coming from here. Then second line, enter your name again is coming from here. And then line number 3 is here. And then once it is done here, then it comes back line number 4 here. Is it okay, everyone?
Sandeep, why did it ask us to enter twice? Why
What?
not 3 times? Because you have still haven't put dot after you enter Giri, right?
Yeah, but here in the first function, there is no if-else condition. So here, if you see, read text 1 is taking the name from you and then calling this other function. And what is the other function doing? It's taking the name and printing it back. So here, when I say Giri, it was here, not here. Okay. And then it printed. So let's go step by step what's happening. Yeah. Okay.
Sandeep, here the text is the two different variable, right? So we allocate the memory to the
Yes.
different variable, right?
So this text will be visible only inside this function. Okay. Here the text will be Giri. Since the second entry is going in this function, then it basically finishes its lifetime. When it comes back, this variable is still this text here. When I entered Sandeep, the text contained the value called Sandeep. But here, when I entered it, here text is equal to Giri. So both are having different values. Okay. And
Same
just in
thing is
case you want to clear this confusion, you can do this. Okay, you can say put 2 and 1. Okay, so if you take a look here, so Sandeep, Giri, and C. See, this one means we are inside the one function. So we are saying 1 dot enter your name. It says I entered Sandeep, and 2 dot enter your name, which means we are here and we entered Giri, and then it printed Giri. So you can see it printed Giri. It finished the work in the second function and then came back to first function, and then it printed this one. Okay, everybody, I request everybody to walk through this code line by line. So first, we define this function, read text. What it does is it asks for your name, and then it prints back with welcome. Okay, and I've just put identifiers to the text so that I can identify from which function is going to be called. So I just put 2 dot in both of these print statements. Now, I wrote the second function. What it does is it reads your name, and then in case it's not dot, then it basically calls the first function. Now, first function would ask you your name, then prints it. Then the control comes back here, and then it prints. So you can see the order will be reversed. So first I entered Sandeep, then I entered Giri. So it printed Giri Sandeep. Is this okay, everyone? Are you clear
Yeah.
about it?
Got it.
Okay. Okay. Yeah. Feel free. This is important. Okay. This is important. It's not obvious. It's not common sense. Okay. It's not common sense. If it was common sense, honestly speaking, right, everybody would get on to recursion very quickly. The truth is that recursion is an art. Okay. Now, let me see the comments. Okay. So these two functions are clear. Now, for a moment, let's move on to the next step. We are saying rather than calling the other function, we are calling the same function. Okay, so we are saying if like here, text equals input, enter the word. if text is dot, then it is going to call the same function and then print it. So it's essentially going to make many copies of this function as if there are 1,000 copies existing. First one calling the second one, calling the third one, calling the fourth one, and then finishing it, coming back, coming back, coming back. Okay, so first call will happen, then second will happen, third will happen, fourth will happen, and fourth one, if I enter dot, then it will finish printing that one first, come back, and then print it here, then come back and print it here. Okay. Okay. So this, okay, let me do it again. This is a cow full stop. So you can see first it printed dot, then it printed cow. Imagine that we were here, enter the word, and we entered dot. So it will not go inside it. Instead, it will print it dot. Then, right now, imagine that we said here, let's say cow and dot. Okay. So the moment we entered cow, when text was cow, it did not. This was correct condition. This statement returned true. This if condition was correct, therefore it went inside it and went back again. And then it's waiting here. So first one is waiting here, and till the second one completes. Okay. So essentially it's like one top of another. There is multiple such boxes that is happening. So imagine this, that first we are in a read this function, okay, and again it called another function. Of course, this is R small. Okay, so we are in this function called read recur. Okay, and we are here inside this code. Okay, and it's making a call to itself, read recur. It's basically again here, and then it reads, takes the input, and then prints, and then comes back here, prints. So I hope this makes sense to you. Not making sense? Okay. A, B, C, D, E, dot. So it read the word A, it went into calling the same function again and reading again, and then it basically just waiting. All these calls are waiting to finish, right? When the other one will finish, we will go forward. Correct? Just like this particular situation where the read text one is waiting for read text to finish, this function to finish. It's just holding on there, just hanging in. So it's kind of everything is getting stored in the memory, and it's waiting for the second one to finish so that first one can continue. Okay.
Sandeep, I have one doubt.
Yes.
Suppose this is the inner function, this is the nested looping, and suppose we have the 1000 iteration for the
Yes.
recursion final condition. So lots of memory will be the consumed. Suppose we design the compiler or the heavy calculation things,
Yes.
so that will be the create the problem for us, no?
Yes, you are right. This is where the term Stack Overflow comes from.
Yeah.
Okay, you see this website like Stack Overflow? The term
Yeah.
Stack Overflow comes from this. Okay, because if the recursion does not end, it will be overflow, right?
Right.
It will be overflow. Like for example, we defined a function. Saying let's say X, and it's calling itself. Okay, so if you call this function, it will keep, you see the star, it's running forever, it's calling itself, and then here it says maximum recursion depth exceeded. So infinitely, it's kind of stuck in the loop.
Same as
Okay.
the brute force, right?
Yeah. So if you say print dot, okay, and then execute it, you can see dot is going on and on and on and on and on and on and on, and then it will basically stop it.
But Sandeep, can we change that limit parameter? Like in Unix, we have ulimit parameters, and you can do the kernel parameters tuning as
Correct,
well.
correct. So there is a max depth parameter that you can set, okay, for the recursion so that it doesn't end. Okay, so this is a control. This is something as a defense mechanism Python has enforced that you cannot call a function more than 1,000 times. I think by default the limit is 1,000 times, but you can change the limit, right? Okay, recursion limit of Python. Okay, so I think 1,000 times. Yes, by default it's 1,000 times, but you can set it to this. Okay, and okay, cool. So I hope you got a little taste of recursion, everyone. I know that I am jumping to recursion, but I'm going in perfect order. Okay, so
I had a question again.
yes,
Yeah, I missed that. The text value, whatever is user is entering as an input. So is
yes.
it stacking up each time, like all
Yes,
the?
yes. Just like here, what happened was I entered Sandeep first, correct? I entered
Yes.
Sandeep. It went into another function. Then I entered Giri. So when I finished Giri, it finished printing Giri. Then it came back here. Here, when it started printing, it came to the next state when the second function finished. When it started printing, the value of text was Sandeep. So now it printed Sandeep. Got it? So from last till the first. So it will print the last first, then second last, then third last, then first.
But when we like write the statements without that without function, we write text equal to input something
Yes,
and
yes,
print text, and again we assign text equal to something else. And when
yes.
we print, then it's always it overrides. Like the last value is
Yeah,
the
yeah. So
la
if you do it here, if you take this line and put it here, okay? And if you take this line and put it here, it will immediately print whatever comes. Let's say if I say Sandeep, Giri, you see? So the moment it took the from us, it printed and then called the second function. Got it?
Okay, yes.
Okay. Like the other way to visualize it would be that let's say print is here, okay, and print is here. I would put a tab, okay. I would put a, let's say tab, okay. Not like this. I'll just put 1, 2, 3, 4, 5. Yeah. Now see, Sandeep. This is, now we went into the next level. It finished printing the second level and then came back. Can you visualize this?
Okay, yes.
Right?
Yes. Prioritize
Okay.
second first and then coming to first. Okay.
Yes.
Yeah.
Yes. Okay. Perfect. I want to talk about the parameters and return value and work more on the functions. Okay, on the recursion. We'll do many more things with recursion. You'll be amazed. You'll be amazed on the power of this tool. Okay. Did you guys zone out? No? Okay. Feel free to ask. Honestly, I expect a lot of questions. Okay. It took me a while to actually figure out. So this is something that, you know, in my first, I think at D Shaw written test, the question was actually this, that if I ask user to enter and people are entering the words, what will be the order of the output? This or ABCDEF dot and so on. So that's a very that those who did not know the recursion, they ended up basically saying that ABCDE, that sequence, and the reverse nobody thought. Okay, and it is fairly when you will debug your code, you will realize that it's not that straightforward. Okay, perfect. So I hope everybody is clear. What does it mean by a function? Function starts with def, followed by a name of the function. This can be any name you want to give, then brackets, then colon, and then there is a tab or a 4 spaces or 2 spaces, but you have to have consistent. And the way Python would recognize that this function includes this line, this line, this line, this line is by the way of tab. You see, this tab has to be there. And how will Python know that only this line is inside if condition? Because it has the indentation. Okay, so Python is recognizing that what is inside if, what is inside function based on the indentation or the spaces before the sentence. Okay. All right. So basically, this is your name. You can give it any name. This is the keyword def. And these are brackets. I'll talk about how to pass the parameters. Okay. So you can bunch up multiple statement into one, and that's it. You can call the function itself inside the functions. Okay. There are two kinds of functions in Python. There are built-in functions, and there are functions that we define ourselves, right? The way we define. We treat the built-in functions as new reserved keywords, as if you are newly defining new things. And a function is some reusable code that takes arguments as the input and does some computation and then returns a result or results. Okay, we define a function using def keyword and we invoke the function by using the function name followed by brackets. Now, here is the thing. So let's take a look at some more functions. There is a function called max. Okay, this is inbuilt function. Okay, so this function max is taking these arguments. So these are the arguments to the max function. So you can imagine that max is a machine. This function is a machine which took 1, 2, 3 arguments and it returned the max of the two. Okay, so this is like a machine which is taking input, doing the processing of it, and then giving the results. Giving the result means it is not really printing. If you say my number equals this, instead of printing, it will basically store it in this variable. Okay, so this is called the returning. So max function is returning the maximum of the 3 values and putting it into this number. Okay, my underscore number. So essentially you can see that it took the input, these arguments, these are called argument 1, 2, 3. And it is a variable argument function, which means you can keep on adding the arguments. Okay, and it would basically consume these arguments. So these arguments are your input. Sorry. Yeah, these arguments are your input. Okay, these arguments are your input, and it's putting the max value into this. Yeah. Are you okay with this? The return value and arguments?
Yeah.
All right. Let's see how we can define the arguments and then deal with it. So these are called arguments. Like max can work on the array of characters as well, and it will basically return the max value. So max value in hello world is W, because the ASCII value of W is maximum. Those who are wondering what does it mean, I'll just show you. So max of AB is B. Okay, Max of AB is B. Okay, because capital A, capital B has got a different number. There is an internal function called odd, which can tell you the ASCII value based on which it is deciding who is bigger. Okay, so you can see that the ASCII value, the numeric representation of A is 65, and the numeric representation of small a is 97. So small a is bigger than capital A. Okay, you can also check which one is bigger. Okay, so you can see that small a is greater than A, which is true. Okay, so that's why what is the maximum, which is the maximum character out of hello space world? W, right? Because small letters are anyway smaller, sorry, the capital letters are smaller than the lowercase letters, and space is also smaller than that. So basically max of this is W. Okay.
Hey, Sunny.
So yes.
Sorry to interrupt. I typed the question. So why do we even have numbers associated with these letters?
Good question. Good question. So internally, everything is bunch of numbers. Okay. Everything is just bunch of numbers. And the way it is, you know, internally in the memory, it is basically every letter is given a number in a sequence, and then we store that ASCII value. And when we are printing it, it basically translates back the integers, the numbers, into printable value. Okay. So internally, if you think about it, how is a variable stored in the computer? It's stored in a computer by, you can think of that there are many bulbs in the memory, which are either on, the light is on, or light is off. Okay. So the memory is a binary number. Okay. When we say variable, the variable actually stores anything by turning on or off these bulbs. Okay. When we say that we have set memory equal to x equal to 1, it has gone to that particular bulb and turned on that bulb. Okay. And internally, everything is exactly defined by turning on these lights.
Right. So I understand. Thank you for explaining. I understand at the end of the day, everything is binary.
Yes.
Maybe it will come later, but I'm still asking the question. But why? What is the use for us of finding max from hello world? You know, if it were numbers, then I care what is the biggest number.
Yeah. Yeah. So this is just for knowledge. Like if you study further the way ChatGPT works, right? So it translates the text into something called tick tokens. And tick tokens and everything, when you think about it, it's essentially translation of the ASCII codes into some other numbers by combining and creating new symbols and representations. So it's important for all of us to know what's happening underneath. Though this particular example has no value, but you will have I honestly feel that you should know how would you, let's say somebody says that I'll give you one single digit number, convert it into integer. Okay. Convert it into integer. So one way to do it is that, okay, x is equal to this. I will say if x is equal to 1, okay, and num equal to 0 in the beginning, I will say num equal to what? Num equal to 1. Else else if x equal to 2, then num equal to 2. Okay. Else, let's say you are not supposed to use the internal library and you're supposed to convert single digit into a number. Okay. So you can write like the whole logic like this, correct? Else if x equal to 3, this is 3. Else if, okay. Now by now you will be irritated by this. Okay. All right. Let's see if I can have the patience to type this code. Okay. And the programmers by nature are supposed to be super lazy people, right? Okay. So this is, I'm just trying to convert a single digit into, so this is like very annoying, right? If you are doing this way, what could have been a better way? What could have been better way? We could have just said x minus odd of 0. Okay. X minus odd of 0. Sorry, odd. That's it. So whatever number you enter in the string, that thing will convert it into number. You see that? So it is important for us to understand the ASCII values and how to deal with it. Okay. So this is, I hope this made sense to you, no?
So this max function is taking like variable size and arguments, right?
Yes.
So how is this defined?
I'll show you. I'll show you that.
Okay.
Okay. Don't
So
worry.
Sandeep, order function is just converting string into ASCII value, right? And
It's
then
giving you the ASCII value.
ASCII value, right? And then
A single character.
Yeah. Okay. And similarly, in the next minus order, that's just subtracting the stuff, right? And then you're getting the.
So you can just check what is odd of 0. Odd of 0 is 48. Odd of 9 is 57. Basically, the internal representation of 0 character is not 0, it's 48. Internal representation of 9 character, when the 9 character is 57. Am I making sense, or does it look like crazy stupidity?
This ordinal value, this value is only for the string characters, right? Not for numbers. Numbers are no, I'm just confused. Like this is just
No,
string
so
character. It
no.
does not apply to numbers, right?
Yeah. So see, underneath everything is going to be numbers. But when we are printing things, there is a character set. Every character has got an underneath value. Okay. And just like any character, like capital A, small a, 9 is also a character. Okay. And similarly, let's say underscore is also a character. So all of these have a certain value, like tab has got certain value, new line, this is called new line, this is called, let's say, space. So all of them have an underneath representation, uniform representation in terms of numbers. Okay. So every printable character has got a value underneath. Got it? Because character is also a printable text, right? No, not clear. So every character, the printable character or non-printable character, has got a numeric representation of it. Okay.
Yeah, it is applicable only for string values. That was my question. Not for
No,
the integer values.
no, integer values are also a printable characters, right? So when you are, let's say, something is existing in, let's say, A1B, here, this is a string, right? So A is a printable character, 1 is a printable character, B is a printable character. Underneath, A would be represented with some numeric value. This 1 will be present, 1 as a printable character is represented with some numeric value, and B is also like that. So you can take a look at ASCII values, right? So if you go to internet, you'll find ASCII values. Okay, ASCII values, or you can say character set Python. I mean, that's universal actually. It's universal. Not this one. Okay. Okay. Yeah, let's say string printable.
It's not Unicode, Sandeep.
Yeah. So it is Unicode, you're right. Okay.
Right, like the each
Really?
number represent, I mean, each string representing a particular digit, and that's like a Unicode.
Yes.
So whatever you are printing in the order 1 is basically how the number system
Yes.
in the computer is recognizing it, right?
Yes. So that's yeah. So the only question I'm trying to figure out how do I answer the question, that numbers are also having a ASCII representation value.
Yeah.
Okay. That is one thing. And you can find out the character representation of, let's say, 1 is something else. Okay. Or let's say 9 is something else. You can see tab character is 9. Tab character's representation is 9, not ninth character. Okay. So you can keep in mind this part. All right. Did I make sense? No.
Yes, Sandeep.
Okay. So every character has got a numeric value to it, and the numbers itself are kind of printable characters.
So Sandeep, will it impact if we are using 32-bit computing or 64-bit computing in ASCII characters or ASCII table?
Good question. Good question. The thing is that ASCII value set, when it did not have Chinese characters, Hindi characters, English character, like French characters, they were like standard values. But those ones were only taking few. The one character was taking, I think, 1 byte. Okay, it was taking only 1 byte for storage. It was only taking okay. If it is 1 bit, how many numbers can you represent with it? 2 numbers, right? If there are 2 bits, you can represent how many? 4 numbers. If there are 3 bits, you can represent 8 numbers. 4 bits, you can represent 16 numbers. And 8 bits, how many you can represent?
255?
255. 256, right? Yes. So earlier, the character set was only 255 printable characters. Okay. Because of which, like long back, like 80s, and because of which the character was, we were able to store everything using 8 bits. Okay, meaning 1 byte. Okay. And now the character set that we use is called Unicode, which is I think 16-bit 2 byte characters, which is 256 times 256. Okay. And yeah, so this one you can represent so many characters, which comes to something like 600 something, 6,500 something, right? Basically 64K, we call them. So 64,000, approximately 64,000 is the total number of characters that we can represent. Okay. And it could only represent these many, right? So this one takes more memory. Earlier, this year used to take less memory, but now the memory has increased in systems, and that's why. So I think CHR, let's say, what does it mean? Yeah. So you have like these crazy characters. So you can see this number, this Chinese character is represented like this. Okay. All right. Yeah. Okay, this one is not there in the list. So it keeps people keep on appending these new. There is a in the Unicode. Let's just show you Unicode character set. You can actually just run an iteration from 1 to 65,000, and you will see the representation of all the letters. Okay. So let's take a look here. Take a look. So null character, this is usually used in separating the two records and marking that this is where the string has ended. Internally, this is used. This has no physical presentation. There is no character that represents this. This is just to mark the end of text. Okay. Start of text. These are non-printable character. Backspace is a non-printable character. Then the tab, then bell character. Then you keep on going. Where is the new? This was the old one, where it was only up to 159 and so on. But later on, not 159, it must be 250 or something. Yeah, you can see here. It was, it has all these characters. And later on, so earlier it was only up to 255. Okay. Now, new ones, people kept on adding to it. And I just want to see, where is that? There are more and more symbol kept on, as they increase the memory to store a string or character set, they basically, marked it. There are so many new symbols introduced. I just want to see where are Hindi ones. There is a Hindi and there is a Tamil, there is a Telugu, and okay. Yeah. Where is that thing? Yeah, Devanagari, Bengali. So Devanagari basically is also represented in this. Okay. So yeah. So Devanagari is UTF 091. What? No, it should be okay. So 900. 900. Okay, 900. If you say CHR 900. 901. Nah. You are on mute, Om Datta.
U plus 0900 something.
That's
U plus 0.
Okay. Yeah, this is octal number, I think.
Yeah, this is it.
Will that work? This is this would require something. Let me just figure this out. What is the numeric representation? That's all. Okay, never mind. So we'll talk about this. This is essentially the octal number. Okay, we could just see. So
Try like
basically, as people kept
U9.
on moving, yeah, Gaurav, you want to say something?
No, I was saying that instead of U09X, can you try like U plus 094? Might work.
Let me see. You are saying no. It's basically it is. I think I just need to figure out. Yeah. So it's a hexadecimal number. So if you have to convert it into decimal, only then it will work. So you can see 0. This is correct. So from starting from 1. No, starting from 2, 3. What's happening here? 4. Oh, it's starting from 4, 5, 6, 7. Yeah, so you can see that. Okay. So you can start printing from there and that'll be good. Okay. So essentially, right now, this might not look useful. It's just for giving an example, right? So this is something that I want you to think that function is like a machine. You put it input from one end, it gives the output. The input means we are feeding in the parameters, and output means we are getting the return value. Okay. Now we could write our logic and then return things. Okay. So we can basically, when we are printing things, I mean, we can use the built-in functions such as type conversion. Okay. So there are built-in function for checking type. There's a built-in function for printing. There's a built-in function to convert the float into, like converting the string into float. There's a built-in function to convert it into integer, for example. So these are all built-in function. Like if you want to convert this text into numbers, it will get converted using this. And similarly, you have things like float. Float can convert this a decimal number, a string into a decimal number. Okay, so you can also have basically the different kind of functions such as int and float for different. Now you can create your own function. You can basically define function, write the entire thing as part of this. Okay, so I hope this is all good. All right. Now, the another part of the functions is arguments. Argument is something that you pass in here. For example, let's say you want to write this logic that if language is equals to ES, then you print hola. If language is equal to FR, you print bonjour. And if your language is equals, otherwise you print hello. Okay. So like that, you can define your own function. Let's see if you can define. Let's say I want to define my function called average. First argument is X, second argument is Y, and I am printing the average of X and Y. Okay. So when I call average 10 and 12, sorry, this is wrong, right? Okay. Okay. So you can see that I just defined a function called average. What it does is it basically takes the numbers from me and then it is dividing. I mean, it's computing the average. Is it okay? So when I say average 10, the 10 value goes into the X. When I say 12, 12 goes into Y because of the sequence, because X is coming first and 10 is being entered first, and so on. And then it basically does the computation.
So Sandeep, this value already assigned, but if we need to take a value from the user, on the fly, then
yes, you can say Z equals to input.
Yeah.
And then say enter third value. Okay. And we will convert it into integer. okay, or float. Let's just convert it into float, because when the user enters, it will be a string, okay, and then we'll say x plus y plus z, okay, and I'm going to say divide by 3. Okay, so I did this, and third value 1. Let's see what happens. It says unsupported argument because it's supposed to be ZZ.
Yeah.
Okay. Now you can see. I hope this is clear. Perfect, everyone. Okay. Now, let's say I want to assign the average value. I'm saying final amount is equal to average. I'll remove this. I'll remove this internal value. Okay, just because that was just for experiment. Okay, I'm changing my function back to 2 variables. Okay, so now let's say I want to assign the output of average into second function, right? Final is 0. Final is nothing. It's undefined. Okay, we can check, is it equal to none? It says true because it is not assigned. Why? Average is, this average function is doing, it's computing the average. Okay, it's computing the average, but it is just printing it. Okay, you everybody, can you just read through the code? So I'm defining a function average. It's taking 2 arguments, and I am computing average, and then I'm printing that value. Okay, but when I'm assigning the result of average to something, that thing contains nothing. Okay, it is empty. Why? Because this average computed and printed, but did not return. Okay, so the correct average function would look like this. Okay, correct average function would look like this. I would say, instead of printing, I would just return. Now it won't print on the screen. It would basically return the value. So now I can do this. I can say print this, assign it to final, and that's it. So now you can see final. What is the value in final? This is false, but final is equal to 11.0. Do you get the difference between printing and returning? Return, when you return the value, you can assign the outcome to something. Okay.
To the global variable or to the.
What
You
do
can
you
just
mean by
feed in
assign,
somewhere.
Sandeep? What do you mean by assign? So, like, because printing was doing the job, it was giving me the answer, right?
Yeah. Yeah. Assign means I want to put it in another variable. Let's say.
Oh, got it.
Got it. So let's say I want to compute, okay, who will help me with the terminology? When you compute the compound interest, what is compound interest? Interest plus principal is a compound interest, right?
Yeah.
Okay, let's say I defined a function called interest. Okay, what it does is interest takes P, R, and T, and it computes the interest I, P into R into T divided by 100, and then we are printing it. Okay, so it is doing the job. Okay, let's say 1,000, the rate is 6%, and I'm doing it for 2 years. So this is my total interest. Now I want to compute something called compound interest. Compound interest. Okay, PRT. Okay, compound interest is this, right? Or what do you call this thing? Principal plus interest. Okay, so I want to use my interest function. Okay, I want to say return principal plus interest. Okay. Okay, or let's say I want to print this value. I want to print a total equal this, and I want to print this total. Okay. I said that, okay, use the interest function to calculate the interest, add it to the principal, and that's my total. Let's print it. Okay. Let's see if this works. So when I say compound interest, I say 1,000, 4, 5, it will throw an error saying unsupported type on none. Why? Because interest did not return anything. It was basically when it called, it gave me none. When it was called, it gave me none. Because it is printing, it is not returning. Okay, when you say return I, now you can use it. Now it is able to add 1,000 to 200. Got it? Not clear? So printing was just printing on the screen. Return was giving back the value to the caller. Whoever is calling me, I'll give back the value to them. Got it? So basically, when you do just print it, what it does is it sends the output to the monitor, like the screen. Okay. But when you return it, what it does, whoever called me, I will give the value back to them. My job is done. So yeah, it's like I asked you to do the job. Instead of you coming back and returning me the outcome, you went to the press and published in the newspaper. The print is like that. When you say print does that job. That you went to the newspaper and published it there instead of giving me back the value. So that's what was happening. Okay, and this is a genuine confusion that I had when I started coding. That what's the point of return when the print is doing the job? Okay. All right. So we talked about two things. One is return value and the arguments. Okay.
So Sandeep, do we, like in other language, we have a void functions as well, right? And
Yeah.
if we use void, then it means the function is not going to return anything. Do we have something like that in Python?
If you don't return, it's a void.
Okay. I mean, we don't need to explicitly mention somewhere like return none or something, right?
Correct. Here we don't define the return type. We don't define the type of the arguments.
Okay.
We do it in the runtime.
But we can do function overloading, right?
No.
No.
No. It's a very clever, very smart thing. Okay. Like for example, I want to say define. Okay. Define. Okay. Get weekday. Okay. Weekday. Okay. And I want to return, like I want to take the day and I want to convert it into the weekday. Okay. I'll say if the type of day is equal to a string, return day. Okay. Else return Sunday, Monday, Tuesday, Wednesday, Thursday, Tuesday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Okay. And I'll say pick the corresponding day from here. Okay. And append day to it. And that's it. So if somebody says, you know, get me 4, it returns Wednesday. If I say give me Monday, it would return Monday. You see that?
Yeah. Okay. And we can return array as well, right? From the
Yeah,
function.
you can return array, you can return anything. Okay. And you can return multiple values from a function. Okay. Let's say you want to return, let's say,
Sandeep, what is this day -1 is doing here?
So since the day, like fourth day is which day? Fourth day is which one?
0,
Wednesday.
1, 2. Yeah.
Correct. So 0, 1,
1,
2, 3.
3.
3. Yeah. So day -1, which is 3, is this. Because normally we are counting days as 1, 2, 3, 4, 5. While in case of array, the index is 1 less than the normal day. That's why we subtracted day -1. So 4 became 3, and third index is Wednesday. If the array was starting from 1, we would say just day. Okay, that's a common confusion. Okay. And it'll take you some time to get used to this. And this is such a big confusion in the programmer's life that many bugs in software happen just because of this. Just because of this. Like this recent hack, there is this PDF hack using which this attackers could hijack your phone completely. If you're using iPhone, older version, it could be hijacked by sending you a PDF file. And that was basically because of this bug in the PDF reader, where the array index was like just missed by 1. Okay. So yeah. So this is a universal epidemic of the indexing. And I don't hope that it will be corrected, because every programmer is used to it. And people, if you read Dijkstra and other people who actually designed the zero-based indexing, they have a very good reason to choose zero-based indexing. Okay. I mean, you'll learn by the end of the discussion that why zero-based indexing is so convenient. Okay. But yeah, it's going to be a little pain in the beginning. Okay. Perfect. Everybody is okay with parameters and return values. Okay. And similarly, same function can return multiple different types. Same function can get multiple different values as input. Okay. Say you want to return max and minimum. Okay. Let's say you have an array, define, analyze. Okay. It's going to return, analyze this array. So let's say it returns 2 values. One is called max of the array and other is min of the array. Okay. And third is sum of the array divided by length of the array. Okay. So what it does is it basically analyzes whatever array we give. Okay. It basically gives us the max of these numbers, min of these numbers, sum of these numbers, and we can also return, average. So it's kind of giving, all sorts of things. So sum and length. Okay. So it is basically giving us all sorts of things in a single shot. You don't have to define a new object or class to return multiple values. In Python, this is called a tuple, and it is returning a tuple. Tuple is nothing but comma-separated list of values that you cannot change once you have defined. Okay.
Just a quick question on line number 5 in the previous function.
Yes.
You've done a operation here in terms of day -1. Can you just break down that line into what's happening logically there?
Okay. So I am, first of all, okay, let's just break it down. That's a good idea. I'll say prefix equal this, and I'm returning prefix plus day. Okay, so if it returns, it comes Sunday, sun, the prefix will be sun and it will be Sunday, Monday, Tuesday, like that. So I have appended day, a text called day. And what this line is doing, what it's doing, okay, it is first of all converting the day into index, and then from this array, okay, from this array, okay, let's define it somewhere, okay, okay, day prefix, okay, these are day prefixes, okay, I've defined this as an array. I'm saying give me the from the day prefixes, give me the prefix that is existing on this particular index, and then I'm appending this one. Now it makes sense.
Yeah,
So
thank you.
first I define the prefixes. Okay, those are my prefixes. When the user entered a number, it came in the else. Okay, and or we can just say elif type of day equals int, then do this. Otherwise, do print sorry. Okay, and in this case, I'm just returning -1. Okay, so here I'm returning text, here I'm returning number.
This helps. Thank you.
Perfect. Everybody okay with this piece of code?
Yes, sir.
Very, very happy. And feel free to stop me if something is looking awkward. It's completely okay to ask me to rephrase it. Okay, I'll try my best. Yeah, so it's very, very important, because if you are having the doubt, there will be at least, minimum 25% people would have the same doubt. Okay, minimum 25% people have same doubt. Okay. All right, everybody okay with me? Are you guys okay with this? So this
Yes.
I've already talked about. Okay. Void functions are basically something that doesn't have return value. Those are called void. They don't return anything.
Sandeep,
Okay.
one more thing. I have one question. Yeah, returning, we are using the star argument and the star keyword argument. So what
Yes.
is the useful case of this type of argument?
Which one?
Oh, the
Star argument, star marks, and the
args and quarks, I guess.
marks and quarks in Python.
Yeah. So
In real life, we are using that, but sometimes we miss that we are returning the 4 or 5 as a tuple, or we return the star arcs or star arcs.
you are saying when we are returning with asterisk values, correct?
Yeah, stochastic. Which use cases is the best for it? Like, I suppose the 3 argument we are returning in the one function, or instead that return of the star of
Don't
asterisk
worry.
of the.
I'll talk about the variable argument, and you'll get a clarity.
Yeah.
Okay. That is something that you will really like. Okay.
Yeah.
So yeah, I'll talk about that. Okay. So sometimes, like the sum function, average function, what they do is they take the multiple arguments, and you can just use it. Let's say what you can do is, let's say you are defining your average function. Okay. And you want it such that people can enter things as many argument, not only average of 2 values, 3 values. Okay. One way is that you ask people to enter it like an array. Other is you ask them to enter it like a variable argument. So what you can do is you can just say, this is my array that you are taking, and You basically can say sum of array divided by length of array, and that's it. Okay, so you can say average of 1, 2. So you can see that the average of 1, 2 is correct. Then you can call it with 3 arguments. Okay, 3 arguments. And you can call it with 4 arguments. You can call it with 5 arguments. Okay, and so on. It's such a simple thing, right? So you can just have as many arguments as you want. If you basically
Sorry, do we have the iterator on the argument? Can we iterate to it? I mean, over here,
it's just an array for you. If you see what is this, this is essentially an array. It's a tuple for you. It's a tuple. So you can essentially say, you can go over this list one at a time and then put the loops. Okay, I'll talk about the loops and everything, and then I'll talk about the variable arguments in more details. Okay. So you can iterate over it. You can do all of that. Happy, everyone?
I have a quick question on list in the earlier thing, right? So no, slightly up. Yeah. So if in this list, right, the days, right? If I want to have a subset of the list based on the value,
okay,
right, not on the index. I mean, index, you showed us that we can use colon and then we can do, right? But if I want to have a subset with value, how can I do it? You said that we can use dot remove. It can remove, but that is.
What do you mean by subset? Are you saying
subset in the sense, for example, if I want list of days without Monday or without Sunday, right?
Without Monday or without Sunday, okay?
Yeah, without changing the list or making a copy.
Okay. Let's say you have this one. Okay, you have this one, right? This one, correct? So what you can do is, what you want is, let's say without Sunday, correct? So what you'll do, you will say, this is pretty simple. Let's say without X, okay? Without X index, okay? Let's say X is equal to, for now, 0, correct? So what you'll do?
No, sorry. Right. So I don't want to do it with index. I mean, with index, we know, right? We can use colon and we can split it. I want to do it based on value.
Okay. Okay. So one is that you find that particular value in this index and then pick those and pick rest of them. Find the index of those values and then do it with using the index. That is a better technique. Rather than deleting or other things, you do it based on the, basically do a subset. Like you can say, give me everything from the starting till X, and then do that. You say that, okay, rest of the things starting from here, you give me this. Okay, so whatever value you set, it will basically remove that. Okay. Okay, so, and
okay,
yeah, like that. Okay.
Yes, Sandeep, but suppose my list is the 10,000 element, and I figure out the 5,001 element, then iteration is the so much costly in behalf of the.
Yeah. So in such cases, what you usually do is you define them as a set. There is something called set. I'll come back to that set. So in such cases, if there is I have to very frequently remove some element or add or check these things, I would just create a dictionary or a set, and I'll basically say this minus Monday. Okay, so okay.
Find the subset.
And okay, so it did not work. All right, let me just see if it works.
Sandeep, can we use slice here? Slice, array slicing.
Slice is something that this is called slicing. This.
Okay, okay.
Yeah, yeah. You can definitely use. So I'll talk about this. If you have, let's say, a big list of numbers and you quickly want to remove Tuesday from it and Wednesday from it, set will be the right way because set is faster because it is already indexed and sorted and everything. So I'll talk about the data structures and algorithms soon. Okay, I'll talk about this. Don't worry.
Yes.
I just want to, go a little slower. Okay. Yeah. A question from Subodhi. I have one question about the list. Maybe we can add the.
Yeah, no, it is the same question which I asked. Yep.
Okay, great. Okay. Yeah, thank you, Samir. You can remove the particular value using the remove. That's the answer from Samir. That's correct. Good. Perfect. Now let's come back to functions, everyone. Let's do some cool things. Okay. How would you multiply two numbers without using loops, without using asterisk sign? Okay, we have to define our function called multiply, or should I give you something simpler? Okay, I just want to do, I think multiply is good, good. Okay, let's say you want to multiply x with n. Okay, you want to multiply x with n. Okay, so can you use recursion to do that? What is multiplication? Multiplication is basically x plus x plus x plus x. Correct. So multiplication of x, n is an integer, please note, and x could be decimal, but n is integer. Okay. And okay. Let me see. Okay. Subodh, is it okay if I take it your question a little while later? Okay.
Yeah, no, I was just replying to.
Okay.
Yep.
Okay. Here, question is good. Thank you, Veena. Multiply x comma y. Okay, let me just copy it and run it. This is good. Okay, super happy. Okay, let's see whether it works or not. So y is an integer, x could be a decimal number. So what is done? If y is less than 0, correct, then it is going to be minus of multiply x minus 1, perfect. If y is equal to 0, then return 0. If y is equal to 1, return x, perfect. If y is equal to, otherwise, this is the most important part of the code, okay? The most important part of the code is, what is multiplication? Multiplication is x into n, okay, x into y, okay, is equal to x plus xy times, correct? Or we can say x plus x into y minus 1. Does it make sense? So we reduce the problem from y to y minus 1, and we keep on repeating the same cycle. And when we reach y, this part at 0, we just go to this. Okay, very well done. Thank you. I think you have covered all corner cases. Okay, and can anybody find loopholes in this problem or the solution? Can you help improving this question? Okay. Good work, Samip. The only problem with your answer is that in case of negative number, your code will not work. Otherwise, it is all good.
Will both the code work for floats, or
If n is float, then it won't work.
Yep.
You're right. So, and the problem statement was you have to multiply x and n, where n is a number, while x could be anything. Okay. I just wanted to make it super simple. Okay. So great. Let me see if I can just reduce some number of characters. Okay. I'm just trying to figure out, can I add any value to this code? Okay, let me see. This particular condition I'm removing for now. Okay. Or this particular condition I'm removing. Okay. Now this is just perfect code. And yeah. So everyone please pay attention. Okay. Let's take a case of what Samip has done. This is Samip, and this is okay, let me just check my name. Bina. Okay. All right. Good. Very, very happy. Okay. So now what you see here is that let's take Samip's code, because Samip's code is a little simpler. Let's say for time being, n is a positive integer, or zero and above. Okay. It's an integer. N is an integer, positive, non-negative. Now it could be 0. So here, and yeah, I'm just changing this, Samit. There is a minor mistake. I think this is better. Okay, so yeah, I hope you don't take offense on this. Okay, so what's happening is that when n is not 0, it goes here. So it becomes 10 plus multiply. So this basically, when you call this, it basically converts into 10 plus multiply this. Yes. Then further, it becomes 10 plus 10 plus multiply with 2. Okay. Let me see if I can align these. Okay. So yeah. And then it keeps on going over and over. Okay. Okay. Yeah. So you can you see the recursion? So first it enters here. The moment we say 10, 4, it comes here. And n is how much? 4. X is 10. It comes here. So it says 10 plus. Then again, it goes back to calling the same function. But this time, n becomes 3. So it becomes x is this. And it keeps on going like that. Okay. So you can see it clearly, everyone.
Yeah.
Okay. Okay. So this multiply, this first multiply get replaced. Okay, let me make it look nicer. So this multiply get replaced with 10 plus multiply 10 times 3, then this multiply gets replaced with 10 plus multiply 10 with 2. Then this multiply, which is 10 times 2, gets replaced with 10 plus multiply 10 and 1. And then this multiplication gets replaced with this. Okay. And this gets replaced with, what is the result of this last value? 0. Okay. So you can see that we have broken down the multiplication into additions without using loops. Okay. Are you getting the feel of recursion, everyone?
Yeah, but fundamentally, just a very basic question, Sandeep. The definition of multiply at the start allows us to then invoke it within the function itself. You don't have to predefine this as a separate function in order to call it within the same function.
Come again?
So line number 3 in the block 167 is your definition of the function itself, and then line number 7 within the function, you're calling it back again. So it's calling itself while within the function. I'm just trying to understand if this is specific to Python, or is this standard?
So this has been by design. It's not by accident. Okay. Because this was introduced, I think, long back in programming languages. And people realized that this has been the most successful representation. Okay. There are programming languages in past which could not give the recursion, but those programming languages did not survive much. I have used one such programming language where there was no recursion. If you call the same function within it, it'll say function not found, function not defined.
Yeah.
Okay. So yeah, it is by design. It is by design. It is well implemented, well protected, and all the libraries, the Python's internal libraries are designed using this. The programming language, Python itself, is designed using recursion, and the compilers are designed using recursion. And almost you will see that when we deal reinforcement learning and all of that, many of those ideas are recursive in nature. Okay, the game solutions are recursive in nature. Okay, so yes, everybody, are you with me? Okay. Okay, wonderful. All right. Okay, Hemant, can I just make a note of your question? Your question is important. I will talk about it. Okay, I'll talk about it. Okay, this is a question that I'm leaving it for now, but I'll come back. Okay. And yes. Okay. Now, I hope everybody is okay so far. This discussion is a little bit advanced, but I want it to be advanced. Okay. And soon enough, you all will be able to deal with it. And if anything is not clear right now, I want you guys to ask me right away.
Yeah, I'm good with it now.
Okay. Who can design me factorial quickly? Factorial of 4 is equal to 4 times 3 times 2 times 1. Factorial of 5 equals 5 times 5 times 4, or you can say 5 times 5 times 4 times 3 times 2 times 1, or you can say factorial of 5 is 5 times factorial of, okay? So factorial of 1 is equal to 1, factorial of 0 is equal to 1. Yes.
Okay.
Can you design it using recursion?
Yeah. So we can define the.
Okay. I'm typing the code. Okay. Okay. Anyway, yeah, I think you guys, I just take 2 minutes time and try writing the code. Take 2 minutes time. I actually missed out walking through Vina's code. That was something that I should have done. Okay. Because couple of cases that she covered were very important. Okay. Okay, but anyway, for now, let's just focus on factorial. Feel free to write your own version. So we need to define a function which takes an integer as argument, or which takes a number as argument, and returns the factorial of that value. Okay, without using the loops, without using any library functions, just use the recursion. Okay, wonderful, wonderful. Okay. So yes, Rupam has done, Rahul has done, Samip has done. Good, very good. Very good, very happy. I just hope that you are not using ChatGPT. Okay. All right. All right. Yes, thank you, Samip. That's the spirit I like, that we are here to make one. Yes. Okay. And yeah. Perfect. Very happy. Very happy. So let me just quickly walk through the code. Okay. Very happy. So what we are doing is we are saying define factorial, which takes a number as the argument. And if number is equal to 0, it returns 1 as return n times factorial of n minus 1. Yes? Okay. Are you comfortable, everyone?
Yeah.
Everyone, please feel free to ask a question here. So it's what we are doing is we are saying if n is equal to 0, then return 1. Otherwise, what you do is compute the just one less than the number. Let's say you are computing for 2 factorial 2. Okay, so what we are doing, factorial 2 is equal to 2 times factorial of 1. And then it goes here again and it checks, oh, it's, this is 1 times factorial of 0. And like that, it keeps going. Okay, 4 times factorial of 3 and factorial of 3 is equal to 3 times factorial of 2. So you can see it's a chain reaction. So when we called it for 5, it called for 4, that one called for 3, then it called for 2, then it called for 1, and then it called for 0, and then it called for this. You can check quickly by putting the print statement, calling for n. Okay, or you can just say n is equal to this. Okay, so you can see first it calls for 5, then it calls for 4, then it calls for 3, then it calls for 2, then it calls for 1, and then it prints this. Okay. All right. Okay, just to be very further clear, let me break it down. I'm going to say print here. Okay, I'll say returning 1. Okay, I'm saying returning 1 here. Okay, and here I'm saying print returning. Okay, this is the value. Okay, now you can see. So first we called it for 5, then for it internally kept on calling until it hit 0, and the moment it hit 0, then it came back, print 1, then print 1, then 2, then 6, then 24, and it kept on going. Why did it happen like this? Why not? Oh yeah, 3 times 2, 6, correct. Then 24, then 120. Is everybody okay? If you say it like 20, okay? Okay. See, what I'm trying to do as of now is I'm more focused about problem solving. Syntax and everything, you can always figure out, do things. But problem solving is something that I want you guys to learn. Okay? You guys should learn with me. This is the most important thing. Okay? Are you guys able to see this? Okay. Now, I'm going to change gear a little bit, and this is going to give you a shocker, and I want to leave it there. Okay. So there is a problem statement called Tower of Hanoi. That's one of the famous, famous problems and puzzles. Okay. So here it is. Okay. So can I see the animation? Okay. So, okay. So basically the problem statement is that you are given bunch of disks, n number of disks. You have to move this from here, this whole bunch from here to the target using this auxiliary. Okay, you cannot keep disk elsewhere other than in one of these poles. Okay, one of these pegs. Okay, and the small disk should never come under the big disk. Or you can say it should always form the tower. Okay, so let's take a look at, say, what happens when you are dealing with 3 disks. Okay, let's say you want to move there are 3 disks and you want to move from A to C. What will you do? First, you will take this one, move it to C, then you're left with this, then this is where you will look like, you will come, and then you'll basically keep on repeating the process. Okay, so the problem statement is you have three pegs. One is auxiliary, the middle one is auxiliary, and the final one, this last one is the target. You have to move the disk one at a time, such that you never place the bigger disk on the smaller disk. Always you are keeping the smaller disk on top of bigger disk. Okay, that is the problem statement. Okay, Tower of Hanoi animation. Where is that? Tower of Hanoi, is there a... I think this is the one. Okay, so let's say we have, say, two disks. Okay, so let's say we have two disks. Okay, let's say we have two disks. Okay, now, first, you will move this final one to here and here. Okay, in this case, the purpose is to move from tower A to tower C using tower A to tower B using tower C. This is auxiliary. This is the target. This is the source. Okay. So now, okay. So what you do? You take the auxiliary, put it in the take the top one, put it in the auxiliary, and do that. Okay. So now you know how to move two disks. How do you move two disks? By taking the one on the top from this to the third. If you have to move two disks from tower A to B, move the top one to C and move the remaining one to B and move back from C to B again. Are you okay? Okay. So if this is my source, okay, this is my source, this is my target, and this is going to be my auxiliary. So I'm saying, right, that first move the top one from here to the auxiliary, move this remaining one to tower B, and that's it. Okay. So you can essentially now using the same philosophy, you can also do it for 3 now. Let's reset it for, say, 3. In case of 3, what you can do, okay, what you can do is take the top one, okay, top one, move this to auxiliary, okay, move this to auxiliary, and then take the bottom, there will be only one left, okay, and move this to here, okay, and then take these two, okay, take sorry, no, I'll do it the other way, okay. We know how to move 2, right? We know how to move 2. We use that algorithm to move 2 from here to here, and here to here. So we move here. The last one, we will move here, and then we will move the 2 back again on top of it. Okay. So we know how to move 2, right? So we can move using those 2 and do that.
Yes, Sandeep, tower C is the final place, right, where the disk have to move.
No, in this case, it's tower B. Okay.
Okay. Okay.
Okay. In this case, it's tower B. Let's start. So
yeah, you can put it in B and then C.
Yeah. So
B to C.
Now we moved 2 from A to C so that we can move this here. And that's about it. Since we have learned how to move 2, we can repeat the process for 3. Now, since we have learned how to move it for 3, we can move it for 4 and we can repeat the process. Okay? No, not clear?
Clear.
Okay. All right. Now, let's say I'm defining a function called move to. Okay. It takes source, target, and auxiliary. Okay. You will give the name as per your requirement. Okay. And I'm saying if you want to move 2 disks from source to target, okay, what will you do? You will first move, all right, move, let's say 1 from, what did you do? Let's say in case of here, 2, right? So first I moved from source to auxiliary, okay? I moved 1, the top one, from source to auxiliary, okay? I'm saying move 1, the top one, from source to auxiliary, okay? Then move 2, the second one, from second one, the second one, from the source to
Target.
from source to target, and then move the one that was lying in the auxiliary, okay, back to target, right? So basically we can just check if it is functioning correctly. Okay, move, let's say we are calling source as A, target as, what is the target in this diagram? Target as B, and auxiliary as C. Okay, so we moved 1 from A to C, 2 from A to B, then 1 back from C to B. Is this clear, everyone? If you have to move 2 disks? Yeah. Now, can you use this technique to move 3 disks from source to target using auxiliary? Okay, so what we can do is we can use this function. We can say, okay, first, if you have to do this, first take top two, put from A to C. Okay, take from source to auxiliary. We'll move 2 from source to auxiliary using target. Okay, then we will say, okay, print move 3 from, okay, from source to target. Now move these, the one that you moved to from auxiliary back to target. Using source as auxiliary this time. Okay, so let me see if I could. Okay, do you think it'll work? So I'm moving 3 from A to B using C. Okay, so as per my algorithm, it says first move 1 from A to B. Okay, move 1 from A to B. Okay, not bad. Move 2 from A to C, correct. And moves 1 from B to C, and then move 3 from A to B, and then back from this, okay, Yes, so I think my algorithm is correct. Everyone? All right. Do you guys want to give it a try? I have not coded it yet. I have only, first I solved it for 2, then I solved it for 3 using 2. Okay. Now, based on this one level of recursion, can you do for any number of disks? Okay. All right. All right. Everyone? Yes, everyone. I want you guys to take this as homework. Study this problem. And trust me, the more you struggle with this problem, the better you will get. It's not the time lost. Every second you spent on this problem, it is adding to your understanding. I have spent very decent amount of time on these problems, and that's why I'm able to solve these, not because that my brain is any bigger than anybody. Okay, so my request to everybody is that take your time, try coding the recursion for Tower of Hanoi. Okay. Sameep's question is, it is n factorial. Okay, yes, it's n factorial, but can you do a better job? I think it's more than n factorial. Okay. It's n factorial in the same range, but you have to prove it. Okay. Think about it. Think about it. Okay. And yes. Okay. So request to everyone, give the Tower of Hanoi your full attention. Give it your full shot. And you will start to appreciate the recursion much more. Okay. The purpose of the class is not Python. Purpose is to be able to solve problems. Okay. The languages will come and go, but this knowledge of recursion, this knowledge of expression, conditions, logic will remain with you. And it's common across all languages, that whether it's JavaScript, C++, C#, Java, or any language, every language has recursion. Everything that you see on the internet is based on recursion. Like when your HTML is rendered in the browser, it recursively renders all the blocks. Okay. So the recursive pattern is everywhere in computing. Okay. I'll talk about the performance problems, but this is something that I want you to spend time on. Okay. So everybody, spend good time going through the Tower of Hanoi problem and struggle with it. You will enjoy the beauty of it. Okay. You will be you will start to enjoy that part. Okay. So I'll talk about Sudoku. I'll talk about more problem like tic-tac-toe and how do you solve these challenges. Okay. So I think, yeah, you guys should, let's discuss and continue from the Tower of Hanoi. Okay. Yeah. All right. Good. Wonderful. Thank you, everyone. I hope this session was good. And I look forward to see you tomorrow. We'll continue from here. And yes, everyone, please keep your cameras on. That's a very big, important thing. It's, yeah, it makes me feel good. Okay.
Thank you.
Yeah.
Yeah, Sandeep, just stay on the call.
Yes, yes. I'm on the call.
Thanks, Sandeep.
Thank you.
Bye. Have a good day.
Thanks, Sandeep.
Thank you, everyone.
Hey, Sandeep, you will be sharing the notebook, right?
Oh, yeah. I'll just right away share. Can somebody put it in that group?
Sure.
Thank you, everyone. Yeah. Have a good day.
Thank you.
I'll be in the call till the end, so you guys can drop if you don't have any questions. Okay.
You will cover that lambda function later, right?
Yeah. Not worry. That one is like much more simpler than the recursion. Okay. Yeah. So I will actually, that would be needed for us to, there are a couple of things that functions are just another data type. You can pass functions to a function. Then we'll also talk about how do you create classes and objects using function without using classes and objects. Okay.
Yeah.
That is called, what do you call that? There is a term for it. It's closure. So we'll talk about closures. Yeah. I think let me just finish the loops and then I'll talk about it. Lambda function is actually pretty simple for you. Okay.
Yeah, it's a kind of inline function, right? If we
Yeah.
check with the C++.
Yeah, function without the name.
Without the name, yeah.
Right, just change it. I will be staying in the call. Somebody had a question.
Sandeep, I have one question regarding the career. Can I ask?
Yeah, go ahead.
Basically, right now I am working in this IT industry from last 4 years.
Which
So
industry?
This IT industry.
Okay.
CSE background. So last 5 years I am working on it. So I hands-on my web development, full stack. I am working on it. So that's why I take this course for the future scope of the data science and the ML.
Yeah.
So I am much familiar with the Python and the everything, but this thing I need to more learn for the future aspect.
Yeah.
So like mathematical thing I need to learn for the machine learning part, or the like I want to much good grades and the much more knowledge, deep knowledge, because you understand maybe.
Yeah. You are in right place. You are that. You will enjoy it. You are in the right.
Can you please guide me a little bit?
See, I would say that whatever we are doing in the class, like Tower of Hanoi, for example, work on. Okay.
Yeah.
Everything is aligned and work on it and solve more problems. Okay. We'll do maths, and the way we'll do maths is way different than the way everybody else has done maths. We will do maths and data structure algorithm together. So we'll be coding most of the algorithms in the class. Okay. That will not only clear your grasp on algorithm or your understanding of the particular problem, but you will essentially solve all the whole range of problems. Okay. So yeah, and things are so simple and so difficult at the same time. Okay.
Yeah, because based of my experience, everyone I go for the further interview and they must be interested of the deep knowledge of the data structure of the background thing, everything. So that's why.
Don't worry about it. Don't worry about it. You will essentially you keep going in the course, and I do not want anybody to believe that you need to finish linear algebra before coming to my class. Okay, you don't. Okay, because a big trouble, like most of the professors or most of the lecturers, most of the courses, what they do is they ask you to finish algebra, statistics, calculus, and then come to the class. And that's one of the reasons why people don't attend those classes, because people start believing that, oh, just because they have not finished all of that, I'm not able to understand this class. But the truth is that the explanation is bogus, because if you are relying on that, if you are just shifting the blame on individual for that, it's wrong. So I think that's why I will assume that you have no knowledge of statistics or linear algebra or calculus, and we will start from there. Okay, and the
Yeah.
beauty about is that even if I'm repeating, because I'll be repeating calculus in the numeric way, I will be we will be coding the class calculus, like the differentiation, in a numeric way that even mathematicians have not studied. Okay,
Yeah.
so you will.
We need to learn about the coding part, not about the teaching of someone or the writing the paper, right?
Yeah, because I'm like, I usually have seen that most of the top companies or most of the good companies, when they are interviewing you, they will ask fundamental questions.
Yeah.
Okay. They will not ask like, tell me about decision tree algorithm. No. Okay. They will not ask like, what is neural network? No, they won't ask. They will ask a technical question, non-obvious.